Good morning and welcome to Unit 2, Properties of Angles and Triangles. Let's begin. We'll begin today with section 2.1 on exploring parallel lines. The goals for this unit are to proving properties of angles formed by intersecting lines, proving properties of angles in triangles and other polygons, and using proven properties to solve geometric problems. Question 1. Definition number 1 is parallel lines. The definition of parallel lines are two lines that will never intersect. If you imagine train tracks is the one that first helps people think of parallel lines. These are two lines that will never meet, and they are indicated by these little marks right here. This indicates that those two lines are parallel. If we added a second set of lines this way, and they had two marks, two little arrows, that would mean that these two lines are parallel with each other, but they're obviously not parallel with the first set. The next thing to understand is a transversal line. A transversal is a line that intersects two or more lines at distinct points. We have an example here with a basketball net. If these two lines right here were your parallel lines, the transversal line is right here. It intersects the two parallel lines at two or more distinct points. Using it in our own example here, we've got our two lines. A transversal line would look something like that. It's a line that is going to intersect through two or more lines. Now there are properties associated with transversal lines through parallel lines, and we'll get into those as we continue. The next definition to understand is interior angles. Interior angles are any angles formed by a transversal and two parallel lines that lie within parallel lines. So in this example, the interior angles are A, B, C, and D. Okay? They fall within what you can imagine as an imaginary box here. If you think of this as a box, these four angles are interior angles, and out here would be exterior angles. We'll get to that in a minute. So once again, interior angles are any angles formed by a transversal and two parallel lines that lie within the parallel lines. As mentioned, exterior angles are any angles formed by a transversal and two parallel lines that lie outside the parallel lines. So again, if you imagine our little imaginary box here, these four angles are outside of the box, therefore they are exterior angles. Okay? The next definition to understand is corresponding angles. Corresponding angles are one interior and one exterior angle that are non-adjacent and are on the same side of a transversal. Now, that definition may sound a little confusing to you. I'm going to make it easier. Corresponding angles make the same shape. So the corresponding angles, they always match up. There's one interior and one exterior. So if I'm making this exterior angle, F, like that, the corresponding angle to F is angle D. As you can see, it makes that same L shape. Carrying on, angle E corresponds with angle C. Corresponding angles make the same shape. As I'm sure you can imagine now, angle A corresponds with angle H. And finally, angle B corresponds with angle G. So corresponding angles make the same shape. And very important here, corresponding angles are equal. So if we know the measure of E, we know that angle C is the same measurement, as corresponding angles always have equal measurements. That'll be important as we get to the examples. It is important to note when a transversal line intersects two lines that are not parallel, the corresponding angles are not equal. Okay? So all these rules for transversal lines and angle properties, they only work if the lines are parallel. These lines, as you can see, are not parallel, as they will eventually meet here. So those rules don't apply. Most of the questions we're going to do deal with, transverse or with parallel lines. Okay. So here's our first example. We are asked to find all of the missing angles. We are looking to find 1, 2, 3, 4, 5, 6, 7. 7 missing angles. Okay? So let's give it a try. The first thing I'm going to do is you have to remember what your angle properties are. So I'm going to look for corresponding angles. Angle 140 corresponds right here. Right? This is the same shape. So this one has to be 140 as well. The next thing I have to remember is what is the measurement of a straight line? The angle measurement of a straight line is 180 degrees. So this angle right here, these two angles, together they make a straight line. So these two angles have to add to 180. So if this first one is 140, 180 minus 140 is 40 degrees. So now this angle right here is going to be 40 degrees. If that angle is 40 degrees, it corresponds, right? The angle 40 corresponds with angle 40 up here. So this one is 40 as well. Now you can see that if we look at the straight line this way, these also make a straight line, so they have to add to 180 as well. So if that's 140, this is going to be 40. These two angles have to add up to 180. So if that's 40, then this is 140. Same thing down here, 40 and 140. So from that first angle measurement of 140 degrees, we were able to fill in all of the missing angles. This one's your turn. I'd like you to find the missing angles. So please pause the video and give it a try. The answer is, let's grab my calculator. (180 minus 66). This is 114. This one is 66. 114. Down here we have corresponding angles. So they are all going to be the same as well. And there's our answer. 114 and 66. Next question. All right. The next one here asks us to find the value of A in the following diagram. So here we don't have an angle measurement, but we have one that says 2A and one that says 4A. And they want us to find what is the angle measurement for A. At first glance, this one's a little bit different. We're going to have to think about it. What do we know about these two angles? We know that these two angles have to add to 180 degrees. They have to add to 180. Therefore, we're going to write that down. 2A plus 4A has to equal 180 degrees. Now it's just a matter of solving for A. 2A plus 4A is 6A equals 180. Divide both sides by 6. A equals 30 degrees. So the angle measurement for A is 30 degrees. Let's do another one. This time we've got a few more letters. We've got A's, B's, and C's, and we have to find the value of, excuse me, A, B, and C. So for this one, the first thing, and again, this is just about writing down things you know and then seeing what you can use and what you can't use. Angle C is going to be equal to 2B, as these are corresponding angles that make the same shape. Okay? So, if those are equal, we know that C equals 2B. And then we also know that 3C and 2B have to add to 180. So 3C plus 2B equals 180 degrees. Now, at this point we can't solve this, right, because we have two different variables involved. But we know that C equals 2B. So we can take out the C and we can put a 2B in there. 3 times 2B plus 2B equals 180. We solve this. 3 times 2B will be 6B plus 2B equals 180. That'll be 8B equals 180. B will be 22.5 degrees. Well, if B is 22.5 degrees, we know 2 B's is equal to C. So if I go C equals 2 times 22.5, I know that C has to be 45 degrees. The next thing is I know that 2A and 2B have to add up to 180. So 2A plus 2B equals 180. I know what B is. B is 22.5. So I can sub that in for B. And I can solve this. 2A plus 45 equals 180. Minus 45 from both sides. 2A equals 135 divided by 2. A equals 67.5. So your answers are, mark those in yellow. B is 22.5, A is 67.5, and C is 45. So that one was a little bit trickier. We just had to maintain or remember the properties about corresponding angles, and then we were able to figure that one out. That brings us to the end of today's lesson. Your textbook questions are page 72, numbers 2, 3, 4, 5, and 6. Thank you. Have a good day.